This is section 4.1, an introduction to fractions and mixed numbers. We already talked about whole numbers. These are used to count whole things, but to refer to a part of a whole, we use fractions. So a fraction is a number that looks like a divided by b, where the a and the b are both integers and the b is not 0. And the parts of a fraction are the numerator on the top, or the a, the denominator on the bottom, or the b, and the line between them, the division line, is also called a fraction bar. So here are a couple of examples. If we have the fraction 4/7, then the 4 would be our numerator, and the 7 would be our denominator. In this fraction over here, the 12, since it's on the top of the fraction bar, is the numerator, and the 13, since it's under the fraction bar, is the denominator. Now remember, when you're working with fractions, that the fraction bar means division. And since division by 0 is undefined, if we have a fraction with a denominator of 0, it's undefined. One way we can visualize fractions is to picture them as shaded parts of a figure. So here are some pictures and the fractions that they represent. Here we have our box. There are 4 different squares in the box and only one of them is shaded. The 1, as the numerator of our fraction, represents the number of parts that are shaded, and the 4 represents how many parts there are altogether in our picture, how many equal parts. So here's what our fraction would look like, and we would read this as 1/4. In this one we have 6 equal parts in our picture, and out of those 6, 1, 2, 3, 4, 5 are shaded. For our fraction, we end up with a numerator of 5 and a denominator of 6, and we would read this as 5/6. And notice this is split actually into 3 different pictures. So we have one whole picture here, we have another whole picture here, and another whole picture here. So altogether, in each one of these pictures we have 3 equal parts. So that's going to be our denominator. And then the number of parts that are shaded out of the whole picture are 7. So that gives us a 7 for our numerator. This would be read as 7/3. Okay, here's one more picture, and let's figure out what fraction this would represent. So if we look at how many of these triangles are shaded, there are 4 that are shaded, so that's going to go on the top of our fraction. And then the number of equal parts we have, since we have 8 equal sized triangles, then we have 8 equal parts. So here's our fraction, and we could read this as 4/8. So here are a couple of examples for us to do. And in this one, we're going to draw and shade our own picture to represent the fractions. So in this one, since 1 is our numerator, this would be the number of parts that are shaded. Our denominator is 6, so this would be the number of equal parts in our picture. So if we just do a long rectangle and we divide it into 6 equal parts, there's our whole, and then we're only going to shade one of those parts. So here's our picture. Okay, in this one we have 5 for our numerator, so that's the part that's shaded. We have 9 for our denominator, so that's the number of equal parts we want to have in our picture. Let's do this one as a big square. So here we have 9 equal parts, and to represent this fraction we're going to have to shade 5 of them. So there's 1, 2, 3, 4, 5. Okay, now one last example here. We're going to write a fraction to represent the following information. Of the 32 students taking Calculus 1, 19 are freshmen. Question is, what fraction of the class is freshmen? So we can think of our calculus class as a whole with 32 equal parts. which is the total number of students in the class. And then if we were thinking about this as a picture, then the number of freshmen is 19, and we'd have 19 freshmen that we're trying to represent. So this could be, if we were drawing a picture, this could be our part that we would shade. That means that 19 is going to be our numerator, and that means that 32 is going to be our denominator. So our fraction is 19/32, or you can also read this as 19/32. Okay, a few definitions. There are some different terms that we use with fractions. The first one is a proper fraction. This is a fraction where the numerator is less than the denominator. And proper fractions have values that are less than 1. So if you look at a proper fraction as a picture, not all of the picture will be shaded. Some examples of proper fractions we've already looked at. Something like 3/7, because the numerator 3 is less than the denominator 7. Another proper fraction would be 1/2. Again, the numerator of 1 is less than the denominator of 2. Another proper fraction would be 63/70, because again, 63 is less than 70. Okay, an improper fraction, it's a fraction where the numerator is actually greater than or equal to the denominator. And improper fractions have values that are greater than or equal to 1. Some examples of improper fractions would be 8/5, because again, the numerator 8 is greater than the denominator of 5. Here's another improper fraction. In this one, notice the numerator of 4 and the denominator of 4 are the same value. But that was one of the possibilities here, that the numerator is greater than or equal to its denominator. And one last one would be 99/98, because again, the 99 is greater than the 98. And last of all, we have mixed numbers, and these are a combination of a whole number and a proper fraction. So these would be things like 1 and 2/3. So the 1 is the whole number, the 2/3 is the fraction. Another would be 5 and 1/4. Again, here the 5 is the whole number, the 1/4 is the fraction. Another way we can look at fractions is to graph them on a number line. This is really just another way of drawing a picture so that we get the equal parts. So for example, if we want to graph 3/5 on a number line, if we look at it first, this would be a proper fraction, because the numerator 3 is less than the denominator 5. And that means that its value is less than 1. So when we graph this, the only thing we have to worry about is going between 0 and 1. So we just graph the 0 and the 1 on our number line, and then we divide the space in between those up into as many equal parts as we need for our fraction. So just like if we were drawing a picture of this, 5 is our denominator, so that's the number of equal parts. So we would draw 1, 2, 3, 4, and there's our 5th equal part. Now if we were drawing this as a picture, the 3 would be the part that would be shaded. So all we want to do is go from 0 up to and count 3 equal parts in our graph, and then at that point is where we're going to mark the graph of our fraction. So one thing to notice here is that each of these pieces in between the 0 and 1 is one of our equal parts. So actually each of these would be 1/5 of the way between 0 and 1. Okay, let's try graphing a couple of these. If we want to graph 1/4, again, we want to notice that this is a proper fraction. We're just going to go from 0 to 1 on our number line. And then in between there, we want to divide that up into 4 equal parts. So there, now we have 4 equal parts. 1, 2, 3, 4. And the number of parts that we're representing is 1. So we're going to start with 0 and count over 1. And that's going to give us the graph of our fraction. So there's the graph of 1/4. This one is actually an improper fraction because the 8 in the numerator is bigger than the 3 in the denominator. So when we graph one like this, we're still going to start at 0. And let's just start marking off equal parts. So there's 1, 2, 3. And notice that since 3 is our denominator, that means that each time we have 3 equal parts, that gives us a whole number. So if we have 1, 2, 3 equal parts, that gets us up to 1. Another 1, 2, 3 equal parts gets us up to 2. And another 1, 2 equal parts. Now we have 1, 2, 3, 4, 5, 6, 7, 8 equal parts. Let's draw one more here so that we can get up to 3. So in other words, each one of these little parts in here represents 1/3. So that's 1/3 between there and there. That's another 1/3, and so on. So if we count up 8 of them, 1, 2, 3, 4, 5, 6, 7, 8, then this would be 8/3. And that's the graph of our fraction. So we're going to look at properties that have to do with 1 and that have to do with 0. So if n is any integer other than 0, then if we have a fraction that looks like this, n over n, where the numerator and the denominator are the same, that just gives us 1. So all we're saying here is that if the numerator and the denominator are the same, then we get 1. So some examples of this would be if we had the fraction 5/5. And if you think about this with drawing a picture or with using a graph, if we drew a picture of this, we'd have 5 equal parts and we'd have 5 of them shaded. So we could think about it this way. So in other words, we're shading all of the parts that are in our picture, which means we're shading the whole thing. So 5 over 5 would just equal 1. And this will be true with any different integer as long as the numerator and the denominator are the same integer. So for example, we could have 1,205 over 1,205. Since the numerator and denominator are the same, that's still going to give us 1. Another property of 1 is that if we have 1 as our denominator, that means we're just looking at having one equal part, so the value of this fraction just turns out to be whatever the number was in the numerator. So for example, if we have 4 over 1, that means in a picture, for example, we'd have 4 parts shaded and we would just have one equal part. So in other words, we'd have 4 holes that would be shaded. Also, for example, if we had 63 over 1, that would give us 63. Another thing to notice is that we can also have negative numbers for fractions. These properties work for negative integers also. So for example, if we had -7 over 1, since our denominator is 1, then the value of this fraction is just going to be -7. Now some fraction properties for 0. If we have 0 as our numerator and n as our denominator, then the value of this will just be 0. And again, if you think of a picture, the numerator is the part of the picture that's shaded, the denominator is the number of equal parts, so this would mean that we would have no parts shaded at all. That would give us 0 for our answer. So again, this is true no matter what the value on the bottom is, as long as it's not 0. So we could have 0 over 3 would give us 0. We could have 0 over 85, and that would be 0 also. Now if we have some integer on the top and we have 0 as our denominator, remember that the fraction bar is the same as division. We can't divide by 0, so this is undefined, no matter what the value on the top is. So if we see a fraction like this, 5 over 0, we can just say that's undefined. Or if we have negative 10 over 0. That's automatically undefined. And the easiest way to remember this is to remember that our fraction bar is division, and we can't divide by 0. Okay, with the definitions we talked about proper fractions, improper fractions, and mixed numbers. So now let's look at how we would go from a mixed number to an improper fraction. So if we start with a mixed number, like 2 3/4, and we want to write it as an improper fraction, then the first step is to multiply the whole number part, which is the 2 here, times the denominator of the fraction. So that means here we're going to multiply 2 times 4, which gives us 8. Okay, then the next step is to take the value we got here, the 8, and add it to the numerator of our mixed number. So we take 8 plus 3. So we're adding those two together. 8 plus 3 is 11. And then we're going to write the number that we got in step 2 as the numerator of our improper fraction. So we take our 11, that's going to be our numerator. The denominator for our improper fraction will be the same as the denominator in our original mixed number. Now we can say that 2 3/4 is the same as 11/4. This is the mixed number, and this is the improper fraction. So it's just two different ways of writing the same thing. Okay, let's look at some examples of this. So we have the mixed number 3 1/2. So our first step is to multiply the whole number part and the denominator of the fraction. So that gives us 3 times 2 equals 6. So that was our first step. Our second step is to take the number that we got here, the 6, and add it to the numerator from our mixed number. So we have 6 plus 1 equals 7. The third step is to write this as our improper fraction. So this is going to be our new numerator. And then our denominator is the same as the one we started with over here. So 3 1/2 is the same as 7/2. Okay, for 2 8/9, again, our first step is to multiply the 2 and the 9. That gives us 18. Second step is to add the number that we just came up with, the 18, to the numerator in our mixed number. So 18 plus 8 gives us 26. And the third step is to write our improper fraction. So this is our new numerator. Our denominator is the same as we had there. So our denominator is 9. So here we end up with 2 8/9 is the same as 26/9. Okay, and finally we have 13 2/5. First step, we multiply the 13 and the 5 and get 65. Second step is we take our 65 that we just got and add the 2 to that to get 67. Third step is to write the 67 as the numerator and then use the denominator from our original mixed number for our new denominator. So this gives us 13 2/5 is the same as 67/5. Now we're going to go the other direction. If we start out with an improper fraction, sometimes it's more helpful to write it as a mixed number or as a whole number if possible. So we're going to look at how to do that. And the important thing to remember here is that our fraction bar is just division. So if we can think of dividing 8 by 3, and we're going to use the remainder as part of our answer for our mixed number. So our first step is to divide the numerator by the denominator. So if we think of 8 divided by 3, that's 2 with a remainder of 2. So remember, when we do this, this part is our quotient, and here we have our remainder. So that's actually all the information we need to write our mixed number. What it's going to look like is this down here. We're going to have our quotient will become our whole number part, and then our proper fraction part is the remainder over the original denominator. Okay, so if we have 8/3 and we divide it and we get 2 with a remainder of 2, then our mixed number we have 2 for our whole number because that was our quotient, and then for our proper fraction part we have our remainder, which was also 2, and then as the denominator of that part we go back to the denominator of our original improper fraction, which was 3. So this means that 8/3 is the same as 2 2/3. We're going to take each one of these improper fractions and write it as a mixed number or a whole number. For each one, we're going to use the fraction bar as a division symbol. So for this first one, we're dividing 38 by 5. And let's even write it out this way. So we have 38 underneath the division box and 5 on the outside. So 38 divided by 5, we could go as far as 7, then 7 times 5 is 35. And now the 3 is less than the 5, so the 3 is our remainder. We have 7 with a remainder of 3. And that means that our 38/5 is the same as 7. That's our whole number part because that was our quotient. Our remainder was 3, so that's the numerator of our fractional part. And our denominator is going to be the same as our original denominator. So our denominator is 5. And that means that 38/5, written as a mixed number, is 7 3/5. Let's do the same thing for 9/2. So that means we're taking the 9 and dividing it by 2. So 2 goes into 9 4 times. If we multiply 4 times 2, we get 8. And that gives us a remainder of 1. So this is 4 with a remainder of 1. And that means that we could write 9/2 as a mixed number as 4. That's our whole number part because that was our quotient. Our remainder was 1, so that's the numerator of our fractional part, and our denominator is the same as our original denominator, so that's a 2. So 9/2 is the same as 4 1/2. Finally, 156/12. Again, we're dividing the 156 by the 12. So 12 goes into 15 once, and 1 times 12 is 12. So now we're subtracting. We have a 6 and a 3, so we have 36 here. 12 goes into 36 3 times, and 3 times 2 is 6, 3 times 1 is 3, so we get 36 there, and then when we subtract we get 0. So for this one we have 13 as our quotient and 0 as our remainder. Since we came out with a remainder of 0, that means that our number is just going to be a whole number. So it's just going to be our quotient of 13. There's no fractional part because the remainder came out to be 0.